Thank you. Good morning, guys. Welcome to my talk. My name is Rosario Valotta, and it's my second time here at Hack in the Box in Amsterdam. This year's topic is abusing browsers' user interfaces for fun and profit. As you can guess from the talk's title, we're going to discuss some vulnerabilities about browser user interfaces. And I'm going to show you a couple of tricks that an attacker can use in order to compromise user security and also get code execution with a little bit of social engineering. Before diving into the technical details, just a few words to better introduce myself. I come from Rome, Italy, where I work as a project manager in a mobile telecommunication company. So this is my daily job, but in my spare time, which is mostly in nighttime, I like practicing web security. I'm active in this field since 2007. I released a bunch of advisories, proof of concept about attack techniques. Maybe some of you heard about cookie checking attack, which was actually released 2 years ago here at Hack in the Box, or my dumb fuzzer, which is a new fuzzer, browser fuzzer released at DeepSec conference in Vienna a few months ago. But I don't want to bug you with all the list of my previous work. If you're interested, you can check them out on my website. Okay, let's start our discussion talking about socially engineered malware. Without any doubt, malware spread is one of the most compelling problems that web security industry has to face nowadays. Malware spread is increasing year over year, and according to some reports provided by Kaspersky Labs, only in 2012, more than 200,000 new malware samples were spotted every new day. And this led to more than 1.5 billion malware attacks originated from the web. But the most interesting thing is that the most of these attacks were originated by user-initiated download. So we are actually talking about more than 1 billion users that proactively downloaded some executable files on their computers, double-clicked on them, and get infected. So when talking about user security, it's quite obvious that you cannot rely on user consciousness or user awareness, because the average user is completely unaware of what he's doing while surfing the internet. Users need guidance, they need protection while surfing the internet. And we can deliver these things by providing trusted and reliable security mechanism. That's why in the latest years, browser vendors invested a lot of money and efforts into building some reliable security mechanism and in making the existing one more robust. And they developed in 4 main areas. The first, protection against memory corruption exploits. And so they developed technologies like ASLR, DEP, GS, and so on, that can make exploit writers' life harder. The second area is protection from web attacks. So cross-site scripting, click checking, and here the technologies names are XSS filters, embedded, for instance, in Internet Explorer or Chrome, or anti-framing technologies. For instance, the X-Frame Reader is supported nowadays by all mainstream browsers. The third area is protection against malware and phishing. And here the technologies developed are Smart Screen Filter by Microsoft, or Safe Browsing API by Google. And last but not least, a lot of effort has been put into building some trusted and recognizable user interfaces to help the user make aware choices while surfing the internet. So when talking about trusted and recognizable user interfaces, we are talking about Chrome. Just to clarify for the few of you that don't know, we are not talking about Google Chrome, Google browser. We are talking about Chrome as all the sets of user controls, interfaces, pop-up menus, notification bars, buttons, whatever, that provide an interface that surround the web content and provide an interface between the user and the browser. So to say it with a couple of slides, this is Chrome, and this is content. Okay? It's not always obvious to distinguish Chrome from content. For instance, this is a screenshot taken from an attack dubbed the picture-in-picture attack. At first glance in this screenshot, it's not easy to distinguish the outer Chrome, which is the authentic one, from the inner Chrome, which is just an image. This is, of course, a phishing attack in which the attacker is tricking his victim into input his PayPal credential into this text form by eventually delivering his this credential not to paypal.com domain, but to paypal.login.com domain, whatever it is. But picture-in-picture has not been the only attack targeting web browser user interfaces in the latest years. Another quite popular attack was URL obfuscation attack. This attack exploits a design flow in browser that are not able to reliably render the URL required by the user. Generally speaking, an URL can embed some credential. And so the general pattern is HTTP username, column, password, and domain, where password is an optional field. So when a victim is tricked into following a URL like this, there is basically a gap between the user perception of the URL and the browser parsing of the URL. So user is led to believe he's going to visit bankofamerica.com, while actually, after parsing the browser, results navigation to that IP. And this was a gold mine for phishers. And this bug was still present on up to a few years ago. Only in the latest browser version, for instance, Opera, Safari, and Firefox raise a warning by asking the user, are you sure this is the IP you want to visit, or maybe you are a victim of a phishing attempt? Internet Explorer took a more drastic approach by completely disabling URL resolution for URL with embedded credentials. Chrome took another approach. It renders the page and strips credential from the location bar, so giving the user a clearer perception of the domain he's visiting. Another quite dangerous attack is a download dialog spoofing attack. As the name itself suggests, this is a spoofing attack against file downloading notification. Basically, the scenario is more or less the following. You visit the attacker website. The attacker website immediately spawns a new navigation window towards a B9 website, in this case, Adobe. After that, the attacker website changes the new navigation window URL towards a URL served with content disposition attachment either. This means that we are starting a new download. And the result is that the file download in notification bar appears in the context of the B9 navigation window. So this led the user to believe that that download is originated by a trusted website. Only after a careful inspection, you can actually notice that there isn't a match between the navigation domain and the originating domain of the download. But not every browser allows you to do this. Only Internet Explorer, for instance, Chrome and Firefox doesn't allow you to make this kind of test. So this is still dangerous and still works on Internet Explorer 9, Chrome 25, and Firefox 19. It has been patched in the latest version of Internet Explorer. So from these couple of examples, it's quite clear that browser security notifications are really important. They're important for several reasons. Because they are a crucial part of the browser trust model. They notify users before making important choices. And they act as a communication medium between the browser and the user. So they need to be recognizable and trusted, so not easily spoofable. Nowadays, two kinds of security notifications exist in modern browsers. Modal notifications and modelless notifications. Modal notifications are the classic dialogues that pop up in the middle of the screen asking you to make some decision. They are characterized by strong visual contrast in order to grab your attention, and they are workflow blocking. So whatever thing you are doing, you have to interrupt your navigation and dismiss the dialogue first. They can be originated by US or by the browser. When originated by US, they usually deals with some important notification by US, for instance, user access control notifications. When originated by the browser, they can be triggered in several scenarios, for instance, notifications from the website, notifications from the browsers, and in some cases, they can be very annoying. So they share a common problem. I called it the default answer problem. Because in order to dismiss them as quickly as possible, a user is led to click on the default answer without paying attention to the message. This is both a technical problem and both a usability problem. Modelless notifications. Modelless notifications are, for instance, the notification bars that you can see on the bottom or on the top of your browser, depending on the kind of notification and on the browser. They are designed in order to inform user, provide information to the user without interrupting navigation. So they stay in the context of the navigation window. They are originated by Chrome, so they are not part of document object model. That means that you cannot interact with that using JavaScript. What they use it for? They are used for file downloading notification, HTML5 APIs notifications. For instance, all those sites using privileged HTML5 APIs, for instance, geolocation API, file screen API, file server API, they need to require your permission before using them. And so they ask you popping up a notification bar like that. They are also used for plugins or ActiveX activation. Lately, we assisted to a shift from model to modelless notification system in all mainstream browsers. For instance, Internet Explorer, Firefox, and Chrome use modelless notifications only, except for extensions or advanced installation, which are quite sensitive actions that need to be clearly notified to the final user using model windows. On the other side, for instance, Safari keeps staying on model notifications only. So modelless notifications are smart, they are not annoying, but they have some problems. First of all, they are displayed even if the window is in the background. Some keyboard shortcuts are enabled for notification bars. Notification bars can be navigated using the tab key, and notification bars are bound to the navigation window and, in some cases, also to the navigation domain. Let's go through each of these. Notifications in background windows. Imagine a scenario like this. You are browsing to an attacker website. The attacker website immediately spawns a pop-up window. A pop-up window is put on the background, so becoming a pop-under. Now a little parenthesis about pop-ups and pop-under. There have been a struggle in the latest years between browser developers and, let's call them, hackers, for the control over pop-ups and pop-under. Because on one side, from the user perspective, they are very annoying. On the other side, they can be very lucrative for hardware distribution and so on. So every time a new browser version comes out, some tricks are dismissed. Some tricks that allow you to control pop-under are dismissed. But hackers find always new way to control pop-unders. So for instance, if you browse over GitHub, you can find a project, it's called JS Pop-under, that still enables pop-under in a cross-browser environment. So we are able to open a pop-under. The pop-under on Windows 7 or Windows 8 is merely unnoticed because several browsing windows are tabbed very closely in the application taskbar. So especially if you have several windows open, it's merely impossible to distinguish that a pop-under has popped up or not. Pop-under initiates a download, so start the download of, for instance, an executable file. A modelless notification is triggered, but on the background window, so it's hidden from the user view. And the pop-under tab doesn't blink to give evidence of a pending notification for the user. So up to now, we launched the pop-under, downloaded the file on our computer, and no notification is provided. This can be very dangerous. I will show you in a couple of minutes. Second problem, keyboard shortcuts. Some keyboard shortcuts are available for activating actions provided on the notification bar. For instance, Internet Explorer allows you to click Alt-N-R, Alt-N-S, or Alt-N-O in order to interact with a file downloading notification bar. It means to press Run, Save, or Open button. Internet Explorer and Firefox also allow this for HTML5 APIs notifications. For instance, by pressing Alt-N-O or Alt-N-A, you can grant this website the privilege to know your position. Of course, in order this shortcut to work, the navigation window needs to be on focus. A third problem, using tab in notification bars. Some browsers allow using tab key in order to navigate among the different options, different buttons provided in the notification bar. For instance, file downloading notification bar again. Internet Explorer allows you to press tab to switch between run, save, cancel option. Google Chrome is a little more secure because in this navigation process skips the file opening button. As I said before, navigation bar is part of Chrome, so no interaction is provided using JavaScript. You cannot you can't generate fake events in order to simulate navigation among buttons. Fourth problem, notification bars are bound to a navigation window. So this means that they can be moved around the screen along with the navigation window, resized along with the navigation window, closed together with the navigation window. In some cases, they are also bound to the originating domain. For instance, you go on google.com, download some file, notification bar is triggered, you move to another domain, for instance, yahoo.com, notification bar disappear, come back again to Google and notification bar pop up again. This can be dangerous in some circumstances. Now, these four problems are, the building blocks for the couple of attacks that I will show you. The first attack works on Internet Explorer 9 and 10, both on Windows 7 and on Windows 8. The attack scenario is more or less similar to the one that we did before. So you visit an attacker website, the attacker website launches a pop-under starts the download of an executable file. All of this is merely unnoticed, hidden from the user view. The pop-under doesn't blink to give evidence of a pending notification. And here comes the bug. Even if the pop-under is on the background, it is the window on focus. So this means that every keyboard input provided by the user will be directed to the window on focus and not to the foreground window. So if you are able to trick your victim to press some keys, for instance, tab and R or tab and space or tab and enter, in order to interact with the notification bar, you can get code execution by just typing some keys. Let's see that in Internet Explorer Windows 8. The proof of concept I talked about is a typing test. You can find a lot of typing tests for free on the web. They will provide you some exercises in order to improve your typing skill, typing speed, and so on. So let's take the first test. Okay, I'm required to retype the highlighted key sequence. The sequence is ERGO tab RX. Let's type. Code execution. Let's stop this because this is actually an adware. I want to show you what happened. Let's resize this. In here. Go back. And let's pop up the virtual keyboard. I want to show you the actual keys I'm typing. Okay. When I start, you see the pop-up window, the pop-under? Look at the Chrome color. The pop-under is on the background, but it has the focus. So, if I just press Tab, and then R is the shortcut for run. It depends on the US language. In Italian, is E, stands for execute. Code execution. So, back to the presentation. Some of you may argue, okay, but it's some way difficult to trick a victim into typing some strange keys, for instance, like tab, because it's not a common key. Okay, but we can do better. On Windows 7, Internet Explorer 9 and 10, by opening the pop-under window using this meta tag, by basically asking your browser to emulate Internet Explorer 7, this will bring the focus of the pop-under directly on the notification bar. So you don't need anymore the tab key because the focus is already on the notification bar. This means that you can trigger code execution by just typing one key. And it can be the R key or the E key, depends on the US language, or space or enter. Let's have a look at this on Internet Explorer. This is Internet Explorer 10, if I remember well. No, it's fine. Okay. The proof of concept is the same. But in this case, I'm just pressing one key. Sorry. doesn't seem to work. Ah, yes, starting. Okay, so let's see again. What happened? What is happening? I hacked the whole system. Okay. Let's pop up the virtual keyboard. I'm just pressing the E key. Okay, code execution. Going back to the presentation, of course, you have a lot of ways that you can use in order to trick your victim to type one key. I mean, a game, a CAPTCHA, a typing test, whatever. So, are there limitations for this attack? I mean, what kind of executable can you launch with this attack? Yes, there are a couple of limitations. The first is a smart screen filter. The second is a user access control. Smart screen system filter is one of the technologies developed by browser developers, browser vendors, in order to block access to malicious files and malicious URL before loading the content. From a functional point of view, they are made up of two parts. On the server side, there is a cloud reputation-based system that scores the web for finding malicious files or malicious URL, categorize them, and assign each of them a ranking. The highest is the ranking, the higher is the ranking, the higher is the safety of the file, let's say. On the client side, there is a browser agent that anytime you download a file from the web, it asks for some reputation information to the cloud system. I mean, this file is sure for opening or is malware, and it receives the feedbacks from the cloud and enforces some warning or blocking functions on the client side. There are two basic implementations of these technologies. On one side, safe browsing by Google that is also used on Firefox and on Safari. It's based on Google Safe Browsing API version 2. It supports URL reputation, so every URL is provided with a ranking. And Chrome also supports our application reputation. Smart Screen Filter is more or less the same thing, but it's based on Microsoft proprietary solution. It was introduced in Internet Explorer 8, and starting with Internet Explorer 9 also support application reputation. With the introduction of Windows 8, Smart Screen has been extended system-wide. This means that a Smart Screen check will be not only performed when you download a file from the browser, but whenever you put a file on your computer using your USB key, CD-ROM, whatever. The first run, a Smart Screen check will be performed. According to these charts provided by NSA's labs, this kind of technology is quite effective. So Internet Explorer 10 using Smart Screen is able to catch almost 100% of malware samples. But if you look on the right chart, they need some time in order to catch the freshly published malware, because they need to collect enough feedbacks from malware intelligence providers and from user agents in order to build a reputation for new files. How does Smart Screen Filter works? Basically, when you are opening a new file downloaded from the web, you are providing server side with your IP, the URL you downloaded the file from, the file hash, the file name encoded in base64, and the signing certificate, if available. All of that encoded in an XML format. And what is the response? The response is a notification bar, ranging in one of these three cases. The first case is about a succeeded check. So Smart Screen is asking you, do you want to run, save, or cancel this kind of file? The second case is about a blacklisted file. So you are actually trying to open a malware. And so the Smart Screen prevents you from clicking the run button. The last use case is about a reputation check failure. This means I'm not sure if the application you're trying to open is malware or not, but being in doubt, I will disable the run button. If you want to run it, you have to first click on actions and then click on run. The bar color changes according to the check result and the signing certificate. I mean, in the first case, if the application we are trying to open was signed, the bar color were green and not yellow. In the last case, was yellow and not red. But there are a number of ways you can use to work around the smart screen filter. First of all, reputation check, reputation algorithm is not 100% reliable. I found a website, it's called minotauranalysis.com. It's a malware intelligence provider website. It provides a huge list of X tweets. An X tweet is basically a shortened URL linking to some malware distributed all over Twitter. And I found that almost 20% of the samples provided in this list will go through smart screen, even being classified as malware or adware by VirusTotal, for instance. More, as I said before, some response, some time is needed for these technologies to catch new malware samples. So if you publish your malware, you have a greatest chance of bypassing the smart screen in the first publishing days. The third way to bypass smart screen is dealing about code signing. Microsoft strongly encourages publishers and developers to sign their application using an authentic code signing. You can buy a certificate like this on GoDaddy, Komodo, Symantec, whatever. It will cost 100, 150 euros per year. They will sell you one without asking too many questions. The reason for pushing code signing is that the reputation algorithm will provide a higher ranking to applications signed with a trusted certificate. Now, there are a couple of considerations about this. First of all, signing an application with a certificate will give you no further assurance about the fact the application you are opening or using is malware or not. Because code signing is just a mechanism to bind a physical identity, the publisher, with a digital identity, the certificate. So from a technical point of view, you can use a trusted certificate to sign some malware and distribute it. And this will work with Smart Screen, because when dealing with signed applications, the reputation algorithm will only look at the certificate ID reputation and not to the application instance. So if you are able to put your hands on or to steal a trusted certificate and use it to sign your malware, it will go through Smart Screen. Or if you have not the chance to steal a trusted certificate, you can go on Symantec or DDCert, and they will sell a brand new certificate type. It's called Extended Validation Certificate. If you buy one of these and sign your application with one of these certificates, it will grant immediately a good reputation for your application, even if your prior reputation exists. So, steal a trusted certificate or buy a new certificate like this. The last way that you can use in order to completely bypass Smart Screen is dealing with internet connection. I mean, it's a client-server technology, so a browser agent needs internet connection to connect with the server side. So, in a man-in-the-middle scenario, an attacker can set up a free access point, trick his victim to connect to that access point, visit his web page, download some malware using the one-key attack shown before, and at that point, the Smart Screen agent will try to connect to Microsoft in order to check reputation for that application. But the attacker can hijack any connection and drop any connection to Microsoft. And what is the result? The result is a new notification bar complaining about the fact that is not able to verify the identity of that executable, but still allowing you to click on the run button. So if you're able to trick your victim to type the R key once again, you're done. And this time it's not normal code execution, it's arbitrary code execution. Let's see that in the demonstration. Oh, close the door. Okay, let's drop in my connection. I'm connected to a local instance of the pro concept. Okay, let's start that. And let's retype the exact key sequence. Arbitrary code execution. What I did is basically I downloaded a batch file asking to make a directory, listen, and popping up talk. Okay, let's connect again and go back to the presentation. Another limitation is user access control. This is a security mechanism introduced in Windows Vista. It basically pops up a dialog asking you for confirmation when an application is asking for administrative privileges. You cannot bypass that. But the question is, do you really need the administrative privileges in order to cause serious damage to your victim? Of course, the answer is no. Just think about Zeus or Kerber that are malwares completely running in a userland mode. They do content injection, keystroke sniffing, and so on. So at the end of the day, smart screen filter is not a problem, and user access control is not a problem. And so using this kind of attack, you can get almost arbitrary code execution. Attack number two. Attack number two deals with a dynamic window overlay. Works on Windows 8 and on Google Chrome and Internet Explorer. The attack scenario is more or less the same. You visit the attacker website spawns Pop-Under goes in the background, starts the download of an executable file. All of these are noticed. At a given point, the attacker tricks the victim to click on a given link or button. And you can track the mouse position using some JavaScript on the foreground window. And as soon as the mouse is hovering on the link or on the button, you can immediately, suddenly, close the foreground window. And if timing is appropriate, there are good chances that the victim click on the underlying window instead of the foreground window. Attacks like this have been already demoed by other security researchers, for instance, Michael Zaleski from Google or Colin Jackson. Colin Jackson actually tested this attack scenario for clickjacking purposes, not for file downloading, on a sample of 2,000 people using the Amazon Mechanical Turks. And he found out that the success rate of this attack is more than 90%. So it's quite effective. So why are we still talking about not a brand new attack? Because on Windows 8, the danger provided by this attack is by far greater than on Windows 7. Every time you download a file, executable file, whatever, using a browser, the OS will write another file to the file system. This is called the zone information file. It is basically an alternate data stream. It's written in an alternate data stream and carries information about the security zone the file were downloaded from. So internet zone, local machine, whatever. On Windows 7, when you download the file and the file is not digitally signed, a security dialog like this will pop up, asking you further confirmation before opening the file. On Windows 8, this kind of control has been suppressed, and a smart screen check will be performed instead. But I've already shown you how to bypass smart screen. So this means that in Windows 8, using this attack technique, you can get code execution by just making one click. Let's see this in action. Let's move to Windows 8. Close this, Google Chrome. Okay. Okay. This is a really simple proof of concept. Imagine you have a photo gallery. I want to click to have a look at my photo. This is a photo screenshot from my last holiday in Sicily with my friends. I really like it, and so I want to like, and suddenly I'm clicking somewhere else. You see? And no notification are provided. Let's stop this. This is a malware, actually. Okay. Other use cases. Geolocation API. Once again, click that. You see, I'm listening to the mouse movements. As soon as the mouse is over the like button, if I'm not careful, I'm granting this website the privilege to know my position. And this thing, sorry, I have an Italian OS. This means allow, don't allow. This kind of approach can be used in other scenarios. For instance, plugins activations, ActiveX activations, Internet Explorer, and so on. Another use case is using this kind of attack as an alternative to click checking. You know that some websites use some technologies, anti-framing technologies, in order to prevent to be framed. Okay, for instance, Twitter, Google, Facebook, some other, I don't know. If you want to click jack this kind of domain, you can use a completely different window and not an iframe. There's another beautiful picture of mine, and if I go to click the like button, you see, if I'm not careful, I'm adding a brand new frame to my Twitter account. So, go back to the presentation. This is the file download scenario, the geolocation API scenario, the click jacking scenario. Some proposal. Notifications on the background windows are useless at best. So why don't let the notification pop-ups after some second since the navigation window has regained focus? An approach like this is already used in Firefox when installing add-ons. There is a timer, the notification bar is not available, you have to wait the timer go to 0 and then install the add-on. The second proposal is disabling tabbing in notification bar. In my opinion, in my experience, tab is completely unnecessary. Just use the mouse. If you are concerned about accessibility, you can still enable, and you want to grant direct keyboard access to the notification bar, you can still enable some complex keys combo in order to reduce the chance of being socially engineered. Third, some sensitive notifications, for instance, file downloading, should ever be kept in a static frame of the Chrome. I mean, you are downloading a file, you have already downloaded a file on your computer. It does really mean to connect this notification bar, to bind this notification bar to the navigation window. Just provide the user some ways in order to inspect the origin domain. Then, some browser-initiated switches between window of different domain should always be combined with graphical effect. For instance, fading, blinking, a light box, in order to give the user enough reaction time to provide them evidence of what is happening. And pay attention to the fact I'm only referring to browser-initiated switches, not switches navigation decided by the user. Just think about the Twitter proof of concept. It was a JavaScript page that was code that was listening to my mouse movement, okay, and decided to switch. So at the end, we can close up some conclusions. Browser shift from model to model-less authentication is still not mature. Implementation are not secure enough to protect the user safety. I showed you at least two kind of techniques that allow for stealth remote code execution. And so, at the end, the joke, while trying to build complex and unreliable exploits, if getting code execution is simple, but just pressing one key. Okay, I'm over. Thank you. If you have any questions.
Any questions from the floor?
Well, I do have one question about the smart screen filter. You explained that it works by checking the hash of the file server side in the cloud service, but how can it know the hash of the file without downloading it first?
Sorry, I only understand hashing the file.
Sorry. How can the smart screen filter know the hash of the file for checking it without downloading it?
No, okay. The file is first downloaded. When the download is completed, the smart screen agent will send all the pack of the information. So the file name, the file hash, and so.
Right.
And then it receives the feedback from the cloud.
So the malicious file is already on your computer
Yeah.
before it is checked. Okay, thanks.
Any other questions?
Yeah, on the right.
The smart screen filter checks for the IP. So what if I would host my file on a valid file hoster, for example, Dropbox or something? Would it then check the entire URL or only the domain to see if it is a trusted domain where I host my file on?
The smart screen will check both. We'll check the URL you downloaded the file from and the application itself. I'm not sure I understand your question.
Does it check the full URL or only the domain? So if
No, all URL.
The entire URL.
Yeah,
okay.
all URL. Because if you think, for instance, at some domain that hosts file for free, CNET, Dropbox, and so ever, you cannot rely on just the domain. You have to check the complete URL.
Any questions? No? Rosario will be here for the rest of the conference as well. If you have any questions, feel free to approach him directly. Thank you very much, Rosario.
Thank you.